In this figure we have a piecewise function, which is simply a function that's defined on given intervals by other functions. In this case we have two lines. One is y equal 2x plus 1, the other one is y equal negative 3x plus 4. So when we graph these, we simply take the section of the graph. For example, the first one's a line. So we want the part of the graph for y equal 2x plus 1 that's contained between negative 3 and 2. And for the second part, we take the graph that's y equal negative 3x plus 4 that's to the right of 2. In other words, this particular one is defined over the interval from x greater than or equal to 2, and this one here is defined over the interval from negative 3 to 2, x greater than negative 2 but less than 2. So we're asked to find the domain of the function, this piecewise function, located in the intercepts, that's x-intercepts or y-intercepts. Sketch the graph, and some of this information can be obtained probably better or quicker if you do the graph first, and then based on the graph find the range. So let's look at this first. I'm going to look at y equal to 3x plus 1. And I'm going to look at some points that are somewhere in this interval here. The end point here, to the left and to the right. So let's let, for this one then, this is the one here. Let x be negative 3. So put a negative 3 where the x is. It's a negative 6. And then a 1. So this particular line passes to the point negative 3 and negative 5. And it also passes to the point. Okay, this interval goes from negative 3 to 2, so let's use 2. Put a 2 where the x is here. 2 times 2. So x is 2. 2 times 2 is 4 and 1 is 5. So with these 2 points here, negative 3 and negative 5, we can sketch the graph. A line passes to 2 points. 2 points determine a line. Now the y-intercept, because it wants us to find the intercepts. So the y-intercept is obtained by replacing the x by 0. So put 0 here, where the x is, and we get 1. So 0, 1 is the y-intercept for this particular line here. So I have it over here also. Now let's let y be 0, and we can find the x-intercept. Let y be 0, so I'm going to get 0 is equal to 2x plus 1. Solve for y, take the negative 1 over here, or add negative 1 to both sides. We get 2x equal to negative 1 divided by 2. So we get a negative 1/2. X equal to negative 1/2. So negative 1/2 is 0. This is the x-intercept. So for the first section, which involves the line y equal to 2x plus 1, we have a y-intercept, we have an x-intercept. Now for the second section here, it pertains to this line. So the equation is negative 3x plus 4. Now remember, for this one we're interested in part of the graph that's to the right of 2, x greater than or equal to 2. So if I let x equal to 0, x equal to 0, and y would be 4. That's a y-intercept, but that intercept is not in the interval, so we don't need this one. We don't get, because we only want the intercepts of the piecewise function that's in the given interval, so that one we don't need. Now what about the y-intercept? We let y be 0, and we solve this equation for x. We're bringing this over. Alrighty, -4 to both sides. We get this, divide both sides by -3, and we get x. X is equal to, divide by -3, so that'll be +4/3. +4/3, and so we have an x-intercept at 4/3 and 0. But 4/3 is less than 2. So we don't use it for this section here. So there we have the information we need here then. Those are the details it's asking for. Now we can get the domain from this. We can see that the graph is going to stay to the right of -3. Because there's no equal there, it stays completely to the right. So for the domain here, and we'll see that a little bit clearer in the graph, but we can say that the domain is a set of all x such that x, notice because it doesn't have an equal on this inequality here. This had an equal, so it would be x greater than or equal to 3, or to -3 I should say. This is the domain. In interval notation, it's this. So for the domain, and you'll see that a little clearer when we do the graph, but it's x greater than or equal to, or greater than -3. X is greater than -3. And then you can also give the interval form. Parentheses here, because it doesn't include the -3. And comma, and then infinity. These are the same. Answer. Different way. And now we locate the intercepts. I gave them to you. The intercepts of the first section here, 2x plus 1, those are the ones we give, because those are in the interval. For the second one, they're outside the interval, greater than, or less than 2. So here we would simply say -1/2 and 0 would be an x-intercept, and 0, 1. So -1/2, comma 0 is an x-intercept for the first section, and 0, 1 is an intercept for that first section. Those are those answers for A and B. Let's clear this. And then we're going to graph this. So from the points that I listed, this point right here, using the first equation, that interval, we go 2 over and plug it into that first equation. This point right here would be the point 2, 5. And because it's at less than 2, this is an open point here. And this one over here is a close point. This is where. And then the other point that we used was -3. So if I go -3 this way, plug it into the equation, -3, plug it in. -6 and 1 is -5. So this point here is also open. There's no equal on that inequality. So this point, label it as -3 and -5. And then for the second one, we use some of the points. There'll be some point over here that we can use to get the graph. And then this point right here, we go 2 units this way. And here is the second equation. Y is equal to -3x plus 4. So if I replace the x by 2 here, this would be a -6 here, plus 4. -6 and 4 is a -2. So this point here is -2, or 2 and -2. And then a y-intercept for this one would be x equal to 0 and 4. But we didn't list that one because that's going to be outside the interval. 0 and 4 would be somewhere up here, in this quadrant over here. So that's to the left of this point here, 2, -2. Or we can use it to graph it. And this graph comes out this way. So it goes out to infinity to the right, And then in between here, it goes from the negative 3 here to the 2. So you can see then the graph basically lies to the right of negative 3. That's why we set the domain was negative 3 to infinity. Now let's look at the range. The range has to do with the y value. So notice at this point, open point here, the graph lies below that. The domain, everything is to the right, everything's included here. And then this point is not included, but this one is. So that will match that one there. So everything to the right is included. Everything to the right of negative 3. So that's why the domain, we listed it above. X greater than negative 3. As far as the range, that has to do with y. So notice, the highest point on this graph is the point 2,5. The y value is 5. But then because this point is not included here, everything is less than 5. And then let's see. So we go down here, we're going down. And remember this point, this part of the graph here also keeps going down forever. It keeps going. So the range of the graph here is from 5 down. So this will be negative infinity, 5. So it's 5, and it's everything down. In set builder notation, you can also write it as the set of all y. So set y less than 5. That's a piecewise function. You're given the domain, the intercepts we found. This is basically your graph right here. And then this is your range. Thanks for watching. We'll see you next time.